Video lecture is about the part 3 of the multiple choice question on solving Schrodinger wave equation for hydrogen atom. How many quantum number have been derived? 1, 2, 3, 4. So there are three quantum numbers: principal quantum number, azimuthal quantum number, and magnetic quantum number that has derived from the Schrodinger wave equation. So the quantum numbers are three that has derived from the Schrodinger wave equation. Which quantum number tells us about the orientation of orbitals? Principal quantum number, spin quantum number, azimuthal quantum number, and magnetic quantum number. So magnetic quantum number describe the orientation in space of a particular orbital, and the orientation of orbital was first observed in the presence of magnetic field. So the answer is magnetic quantum number. The relative energies of 4s, 4p and 3d orbital in the order. So there are four orders given. Which one order is correct? So the relative order of the energy of orbital is determined by n plus l value. If n plus l value are same, lower n value will get lower energy. We will find the value of n plus l. The higher n plus l value will result in a higher energy, while the value of n plus l will lower, then it will have lower energy. If the value of n plus l is same, then we will look at the principal quantum number, that is n. So here the n is principal quantum number and l is azimuthal quantum number. So we will find the n plus l value for each of these pairs. So for 4s, n plus l, 4 is the principal quantum number and l value azimuthal quantum number for s is 0. So it will result in 4. 3 plus d, 3 is the principal quantum number and azimuthal quantum number value for d is 2. So it will become 5. For 4p, the p is the principal quantum number and azimuthal quantum number value for p is 1. So it will result in 5. So 3d and 4p, the value of n plus l is same. If we look at these value, 3d and 4p both have 5 value. So the lower n value will be considered as lower energy. So here the 3d will have lower n value, principal quantum number, as compared to 4p. So the 3d will be at lower energy as compared to 4p. So the correct order is 4s, which has lower n plus l value. Among these two, these both have same n plus l value, but we will consider the lower principal quantum number, that is 3. So it will have lower value as compared to 4p. So the answer is C. Which one of the following pair has the same electronic configuration as possessed by neon, that has atomic number 10? So there are four pairs given. So the sodium ion and the fluoride ion have the same electronic configuration. If we look at the sodium atom, sodium has 11 electron, but here the ion is given, which means that it has lost 1 electron. So it will become 10, as same as neon. Fluoride, it has fluorine in atomic form. It will have 9 electrons, but here it is minus. It means it has gained electron, 1 electron. So it will become 10. So these both has electronic configuration that is similar to the neon. So the answer is sodium and fluoride ions. The sum of principal and azimuthal quantum number for a certain orbit is 4. The orbit may be 3d, 3p, 5p and 4d. 3d, 3 is the principal quantum number, d is azimuthal quantum number, which has value 2. So we will get 5. For p, the azimuthal quantum number value is 1. So we will get 4. Here for 5p we will get 6, and for 4d we will get 6. So looking at these value, we will get 4 value for 3p orbits. So the 3p is the correct answer. Correct order for energy in the given subshell is, so there are four orders given, which one is correct according to the energy wise. So we will use the n plus L value because it is used for finding the order of the relative energies of orbitals. If we get n plus L value lower as compared to the other value, it means that it has lower energy as compared to the others. If we get the higher value, which means that it has higher energy. If we get n plus L value same, then we will look at the principal quantum number, that is n. So here the four orbitals are given and we will find the n plus L value for each of it. For 4s we will get 4, for 3p we will get 4, for 3d and 5s we will get 5. So looking at these four values, the first two values are same and the third and fourth value are same. So we will look at the principal quantum number. So the 4s and 3p will have same n plus L value. So the higher n value will have higher energy, or the higher principal quantum number will have higher energy. So the 4s have higher energy as compared to 3p. Looking at the third and fourth value, that is 3d and 5s, both have 5 n plus L value. So we will look at the principal quantum number. The principal quantum number 5, it has higher energy as compared to 3d. So the correct order is 5s, which has higher energy as compared to 3d. It is followed by 4s, followed by 3p. So the correct order among these all options is C. The total value of magnetic quantum number for a given value of azimuthal quantum number is 2L, 2L plus 1, 2L minus 1, 2L minus 2. So we will find the magnetic quantum number using the azimuthal quantum number using the formula 2L plus 1. So the answer is 2L plus 1. The orbital with n is equal to 3 and L is equal to 2 is 3s, 3p, 3d, 3f. So n is equal to 3 and L is equal to 2. L is azimuthal quantum number value and it is 2 for d subshell. So the orbital is 3d. No two electrons in an atom can have same set of four identical quantum numbers. This is the statement of Ahba principle, Hund's rule, Pauli exclusive principle, none of the above. So it is the statement of Pauli exclusive principle. The similar question is the two electrons in first shell will differ with the value of n, L, m, s. So we will have that no two electron will have the same set of four quantum numbers. So the spin quantum number will be different as compared to others. The other three quantum number may or may not be same, but the spin quantum number is always different. 4s orbital have lesser energy than 3d orbital because it has greater value of n, lesser value of L, lesser value of n plus L, L is equal to 0. So we will use the n plus L rule. If the n plus L value is less, which means that it has less energy. If the n plus L value is high, which means that it has higher energy. So finding the n plus L value for 4s and 3d, we will get 4 and 5 respectively. Now the 5 is higher as compared to 4, which means that the 4s has less energy as compared to 3d. So it will have lesser value of n plus L. The value of azimuthal quantum number for last electron of nitrogen atom is 0, 1, 2, 3. So first we will find the electronic configuration of nitrogen, and the last electron is occupied in the p orbital. So here the 2p3, so the last electron is in p orbital and the value of azimuthal quantum number for p is 1. So the answer is 1. Which one of the following sets of quantum number is not allowed? So there are 4 sets of quantum number given, that is principal, azimuthal, magnetic and spin quantum number, and each value is given. Which one of the following is not correct? If we look at these values, here the spin quantum number has 0 value. It is not allowed because the spin quantum number will either have minus half or plus half. It must have some value. So the answer is D. The sum of all quantum numbers for the electron of hydrogen atom is minus half, 1, 3 by 2 plus half. So first we will find the quantum number for hydrogen atom and then we will sum it to get the answer. So the hydrogen has one electron that is present in 1s1. So the principal quantum number is 1, azimuthal quantum number is 0 because for s the azimuthal quantum number value is 0. If the azimuthal quantum number is 0, then the magnetic quantum number will have 0 value and the spin will have plus half value because it has only one electron that has plus half spin. So summing all these quantum number n plus l plus m plus s, we will get 3 by 2 or we will get 1.5. So the answer is 3 by 2. If the value of azimuthal quantum number is 2, there will be value for magnetic quantum number 2, 3, 4 and 5. So there is a formula that is used for finding the magnetic quantum number using the azimuthal quantum number, that is 2l plus 1. So the L value is given, azimuthal quantum number value is given, that is 2. So 2l plus 1, so 2 multiplied by 2 plus 1, it will result in 5. So the value of magnetic quantum number is 5. The subshell which does not exist has quantum numbers n is equal to L is equal to 0, n is equal to L is equal to 1, n is equal to L is equal to 0 and n is equal to 3, L is equal to 0. If we look at all these three values, it is clear rule that the L value should be 1 point less than the n value, which means the azimuthal quantum number has one value less than principal quantum number. If we look at the option C, both have the same value. It must have 0, it must have 1, but it is equal to the principal quantum number, which means that it is not correct.